Welcome to the mysterious world of Saturn, a gas giant full of secrets. From an artificially appearing hexagonal pattern at its north pole to mysterious downpours falling on Saturn from space. Recently, scientists noticed something weird was happening to Saturn's rings, which made them worry about our cosmic neighbor in the very distant future. Whoever lives on Earth will not be able to see Saturn's majestic rings. But why do astronomers think they're about to disappear? And what are these strange things moving along Saturn's rings? The journey to comprehend this celestial giant began in 1979 with the Pioneer 11 spacecraft's close-up images of Saturn. However, it wasn't until the Cassini mission arrived in 2004 that scientists began to uncover the true wonders of this ringed world. As we continue to study Saturn, the planet occasionally reveals its secrets, highlighting how much we still don't know about its intricate nature. Saturn, the second largest planet in the solar system, has a core that is about half the planet's radius and weighs between 12 and 20 times the mass of Earth. However, what's amazing is that if you had a large enough reservoir to hold it, it would float in water because the gas giant has the lowest density of all the planets in the solar system, at 0.687 grams per cubic centimeter. Not only that, but Saturn is also the flattest planet in the solar system, with an orbital period of roughly 10.5 hours and a remarkably fast spin rate, making the gas giant bulge at its equator and flatten at its poles. The ringed planet, which is roughly 68,000 miles long from one pole to the other and has an equator diameter of 75,000 miles, is caused by superfast winds in its upper atmosphere, which can reach speeds of up to 1,100 miles per hour. However, if you were to look closely at Saturn, you would notice something quite strange. Massive hexagon patterns with a circumference of roughly 20,000 miles or inspiring hexagons with enormous sizes may at first seem like elaborately constructed megastructures, adding to their mystique. The design is changing from a blue tint to a golden one. Cassini's high-resolution photos were meticulously assembled to create an amazing animation that, for the first time, shows this event in vivid color inside the whirling hexagonal vortex at Saturn's north pole. A massive hurricane forms in the Middle East with an eye that is 50% larger than Earth hurricanes. Reddish vortices are dispersed around the hurricane, swirling in unison with the counterclockwise motion of the hexagonal jet stream. Inside the hurricane, the particle composition differs noticeably from outside. Inside, smaller haze particles are plentiful, larger particles are rare, and outside, the opposite is true. One of the most fascinating characteristics of this six-sided storm is its resilience. Whereas hurricanes on Earth typically last only a week, this remarkable hexagon has endured for decades, if not centuries. How does a monster storm like this form? Computer simulation revealed an intriguing phenomenon known as deep thermal convection. Heat transfer through fluid or gas movement can generate atmospheric flows that result in the formation of large polar cyclones and an eastward jet pattern at high latitudes. These atmospheric features combine near the planet's upper regions, giving rise to the unexpected and distinctive hexagonal shape seen at Saturn's north pole. The hexagon's persistence is the outcome of all these storms forming deep within the planet, though there are no other storms like this that scientists are aware of in the cosmos. Saturn's hexagons serve as a testament to the wonders of the universe, but the planet has more fascinating features. Scientists studying Voyager data notice strange, enigmatic spokes across the rings of the planet. But even stranger findings were made during the Cassini mission, when no signs of these ghostly features were found, further adding to the mystery surrounding this unexplained phenomenon. Upon closer inspection, it was discovered that although the spokes appear dark when seen from above, when inspected the spokes are thought to originate from dust particles in the rings that separate from icy chunks and float independently. Researchers are still unsure of what causes these mysterious streaks, but they do know that they reappear seasonally during Saturn's spring and fall, just like here on Earth. Saturn has 4 seasons, but each one lasts roughly 7 Earth years. Above the other icy boulders, it may be caused by Saturn's magnetic field. When the solar wind interacts with Saturn's genetic field, an electrically charged environment is created, and this environment can affect how the charge behaves. Dust particles, which cause them to momentarily adhere to one another and create denser patches within the rings. While other giants in our solar system also have rings, such as the Uranian rings, they are the biggest and most easily identifiable. The 7 rings were named according to the order in which they were discovered. The rings are located along Saturn's equator and start about 4,300 miles from the planet's core. To give you an idea of scale, the E-ring alone spans a staggering distance of approximately 75,000 to 260,000 miles. Imagine a road running the entire length of Saturn's E-ring, from the outer wisps to the inner boundary. If you were to travel at 100 miles per hour non-stop, it would take you more than 2.5 months to get from one end to the other. Additionally, the flimsy Phoebe ring, which extends roughly 100 to 270 times the radius of Saturn, is comparable to the planet's unique shape. The rings of Saturn are very flat. Thorough examinations reveal that although some regions of the rings can attain a thickness of almost 0.6 miles, the main rings are remarkably thin, with a thickness of just 32 feet. When Galileo first pointed his telescope towards Saturn nearly 4 centuries ago, he described the gas giant planet as having ears or handles, which were in fact the elongated bulges that we now recognize in Saturn's magnificent rings. The size range of Saturn's ring particles is vast, ranging from tiny icy grains resembling dust to substantial fragments comparable in size to houses. There are even a few exceptional particles that reach dimensions the magnitude of mountains. We believe we know almost everything there is to know about the powerful rings of the 6th planet, but it still defies our expectations. Galileo was unable to perceive the fine details of the rings, leading him to mistake them for large celestial bodies positioned on either side of the planet. Nearly all of the particles in Saturn's rings are made of water ice, and they are in a delicate balance between 2 opposing forces. Their orbital velocity attempts to push them out into space, but Saturn's gravitational pull draws them towards the planet. Scientists have long wondered if the planet evolved with its rings, and new research reveals that Saturn didn't always have this unusual feature. For over 90% of the gas giant's life, the planet was without rings. Hence, one possibility is that the rings formed later in the planet's history when small icy moons orbiting Saturn collided with one another. These collisions may have been caused by the gravitational effect of passing asteroids or comets. Another fascinating theory that the rings might represent the remains of dwarf planets was put forth in a 2016 study. Through computer simulations, scientists have identified a potential moon called Chrysalis that existed before Saturn's rings formed. They found that Chrysalis was similar in size to Saturn's 3rd largest moon, Iapetus. In the past, Saturn and Neptune's gravitational interaction caused the ringed planet's axis to tilt and wobble in sync with Neptune's orbit, leading to the changing angles at which we observe Saturn rings. This theory suggests that these dwarf planets that met their demise in the distant past now exist as the mysterious rings encircling Saturn. Or it could have just been one large moon that collided with Titan in the past. Titan exerts its gravity on the planet and moves away from it rapidly, while our moon also moves away from Earth, but at a slower pace. Around 100 to 200 million years ago, Titan and Chrysalis entered into a resonance, and as Titan migrated outward, the gravitational forces destabilized Chrysalis's orbit, which caused Chrysalis to approach Saturn and get torn apart by its gravity. Nearly 99% of Chrysalis was absorbed by the gas giant, and the remaining 1% left behind the stunning ring system we see today. According to a recent study, the age of Saturn's rings is approximately 100 to 400 million years, but their existence may soon come to an end. A true celestial marvel causes Saturn's majestic rings to melt away, and in another 100 or so million years they will disappear. Under the influence of the sun's radiation or plasma clouds caused by space rock impacts, the dust particles of Saturnian rings sometimes become electrically charged and disturbed. When this happens, the dust particles bind to Saturn's magnetic field, which then draws them inward toward the gas giant's upper atmosphere. As the gas giant orbits the sun, the planet, and its rings tilt, which changes the amount of the radiation output on its inner ring layers and affects the intensity of the icy ring rain. NASA says the 6th planet's ring system is depleting at an extremely fast rate. It's estimated that every 30 minutes it loses an Olympic swimming pool volume of water, and just recently, after 4 decades of research, scientists have revealed the cascade of ring rain pouring down onto Saturn has an impact on the planet's atmosphere. Every passing second, an astounding amount of up to 6,000 pounds of icy particles previously bombarded by solar ultraviolet radiation gracefully descend onto the planet. As these particles make their atmospheric journey, their accumulated energy is transferred to the surrounding environment through collisions with other particles. This energetic exchange contributes to Saturn's atmospheric heating and may cause glowing bands in the planet's northern and southern hemispheres, but it's not the only rain there is on Saturn. Enceladus, a moon of Saturn, shoots jets of water and ice into space from its underground ocean. Some of these tiny particles are influenced by Saturn's magnetic field and gravitational forces, causing them to rain down onto the gas giant's atmosphere. This phenomenon is known as the moon rain. The chemical mixture that makes up Saturn's ring rain includes some organic compounds as well as water, butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. In the future, this mixture may alter the proportions of carbon and oxygen in the gas giant's atmosphere, which is insufficient for life to exist on Saturn alone. But what about its moons? Music. Saturn was just crowned the solar system's king of moons once more. The ring planet has 62 new satellites orbiting it, for a total of 145 moons. However, 2 of these satellites, Titan and Enceladus, are of particular interest to scientists because they each have at least one element required for life. Titan is known for its thick atmosphere and abundance of organic molecules, such as complex hydrocarbons, which are thought to be the building blocks of life, while Enceladus has a subsurface ocean of liquid water, making it a promising candidate for supporting life or providing the conditions required for life to exist. Titan features rivers, lakes, and seas on its surface, but unlike Earth's water-filled bodies, Titan's atmosphere is dense and resembles that of a planet similar to Earth. It is primarily composed of nitrogen. Titan also has deep liquid reservoirs that are made up of methane and ethane. Although it is highly unlikely that the lipid-based membrane, which is essential for supporting life on Earth, would withstand Titan's harsh conditions, such as its freezing temperatures of approximately -290 degrees Fahrenheit. Scientists have suggested an alternate possibility involving a molecule called acrylonitrile. Methane is a compound linked to the metabolic processes of many organisms, serving as a source of energy. One of acrylic nitrile's special qualities is its propensity to construct flexible, stable structures like cell membranes. This material can first form as a thin sheet, which can then shape into an exotosome, which is a tiny hollow sphere resembling a lipid bilayer. These exotosomes may serve as small receptacles for transit and storage. What interests me about the ALMA, to put this into perspective, it surpasses the abundance of approximately 1 million bacteria per milliliter of coastal ocean water found on Earth. NASA's Dragonfly drone is scheduled to launch in 2027 and will investigate the satellite in detail, bringing us closer to understanding whether life could form on such a celestial body. The observatory has detected significant amounts of acrylic nitrile molecules in Titan's atmosphere, up to 2.8 parts per billion. Scientists believe an abundance of this chemical reaches the surface of the satellite throughout the existence of Titan.